Welcome all. I'm Dr. C. Janita Nancy, Assistant Professor and Head, Department of Mathematics, PPG College of Arts and Science, Coimbatore. System of Simultaneous Linear Algebraic Equation. Introduction. Many engineering, science and mathematical problems involve solving systems of linear equations. Numerical methods provide efficient solutions, especially for large systems. Three commonly used methods are Gauss Elimination Method, Gauss-Jordan Method, and Gauss-Seidel Method. These methods differ in their computational approach and efficiency. Now, Gauss Elimination Method. It is a direct numerical method used to solve simultaneous linear equations. It converts the coefficient matrix into an upper triangular matrix using elementary row operations. The solution is obtained through back substitution. It is suitable for systems with a unique solution. Application of Gauss elimination. Gauss elimination is applied in electrical circuit analysis, structural engineering calculations, finite element method, heat transfer analysis, mechanical engineering simulations, and economic and financial modeling. Advantages of Gauss elimination. It is fast for small and medium-sized systems. It is accurate for well-conditioned matrices. Gauss-Jordan method. It is an extension of the Gauss elimination method. It reduces the matrix to reduced row echelon form. It eliminates coefficients both above and below the pivot. It does not require back substitution. Applications of Gauss-Jordan method. Gauss-Jordan is applied in solving systems of linear equations. It is useful to find the inverse of a matrix. It is used in computer graphics transformations. It is used in robotics and control systems. It is used in image processing and data analysis. Advantages of Gauss-Jordan method. It has a direct solution. It is useful for multiple right-hand side equations. Now coming to Gauss-Seidel method. It is an iterative method for solving linear equations. It starts with an initial guess. It updates variable values sequentially using the latest available values. It continues until the desired accuracy is achieved. Applications of Gauss-Seidel method. Gauss-Seidel is applied in large engineering problems. It is used in finite difference method. It is used in computational fluid dynamics. It is applied in power system load flow analysis. It is applied in machine learning optimization and numerical simulations. Advantages of Gauss-Seidel method. It possesses low memory requirement. It is suitable for very large systems. Comparison of three methods. Gauss elimination and Gauss-Jordan are direct methods, whereas Gauss-Seidel method is iterative method. Always Gauss elimination possesses back substitution, whereas Gauss-Jordan and Gauss-Seidel does not possess back substitution. Gauss elimination possesses upper triangular matrix form. Gauss-Jordan possesses reduced row echelon form, whereas Gauss-Seidel possesses iterative updates. Gauss elimination is best suited for medium systems, whereas Gauss-Jordan is best suited for matrix inverse and direct solution, and Gauss-Seidel is best suited for large sparse systems. Gauss elimination is always fast in calculation. Gauss-Jordan is moderate in speed. Gauss-Seidel always depends on convergence. Conclusion. Numerical methods simplify solving systems of linear equations. Gauss elimination is efficient for direct solutions with back substitution. Gauss-Jordan provides direct solutions and matrix inverses. Gauss-Seidel is ideal for solving large-scale problems through iteration. Choosing the appropriate method depends on the size, structure, and accuracy requirements of the problem. Thank you all.